Hi there, today I'm going to have a go at machining the crankshaft bearings and also the sole plate to accommodate them. So the bearings will be made out of this piece of extruded brass, and I've measured this section here and worked out these approximate dimensions. What I've then done is I've mapped those dimensions onto the side of the sole plate using a scribe. Don't know that you can see that. And what my plan will be to do is to use the milling machine to take 40 thou off each of these sides, just so that this top section fits in there snugly, and I'll be milling down here to a depth of approximately 0.138 of an inch. Okay, so I've used this set square to get the sole plate nice and square and clamped it down nice and firmly. Now I'm going to put this edge finder on here. I've not been very successful in the past with edge finders. I think basically because the one I had was very poor quality and it gave random results, to be honest. So I recently purchased a Stuart one and I'm really happy with it. It gets spot on results all the time. So what I'm going to do is just find the edge. This is a 6mm diameter one, and I'll be cutting with an 8mm diameter cutter. So I'll find the edge and then I'll bring the table across by 1mm to make sure I get the edge again. It's running at 500 RPM. Just found the edge there. Let's double check it. Gone. So I've just zeroed my dial on the x-axis, and I'll actually repeat it on here as well, just to make sure that it is nice and parallel. Just gone. I reckon it's, well, probably out by a couple of thou, but I can live with that. That might be just the where the casting's been made. So I'll change the edge finder now for this 8mm end mill, and like I say, I'll move the x-axis across by 1mm, and that should give me the edge. Okay, so I'm going to bring the x-axis this way by a couple of millimeters. And now I'm going to bring it back this way until I hit the 1mm mark on my dial. And I can just feel it rubbing. That's perfect. Okay, so I've lowered the cutter to the appropriate depth, and I'm going to take off about 8 thou at a time, just on these sides, on the left hand side, and I'll probably take off 24 thou in total. Then I'll repeat the process on the other side, and then I'll do a measurement and see where we are. Remember to lock the x-axis. Increase the speed actually. It's about 1,000. Okay, so it seems to be going okay at the moment, and I've taken about 24-25 thou off each of the sides, and I've also got some scribe lines here as a guide, and like I said previously, I need to be aiming for around about 40 thou off each side. So I'll continue taking off 8 thou at a time, and I'll keep on checking until I get the right width. Okay, so I think I'm pretty much there. Just checking the top width. That's just a snug fit there. So what I'll do now is to take the sole plate off the mill, and I'll use my round file to file off the curve at the bottom. Well, now I need to file the round bit, and I've got this 9.5mm diameter round file, and I saw a tip on the internet recently that suggested putting a couple of bolts through, holding them in on the vise, and just slotting the sole plate on top, and it does actually work very well. So now it's just a matter of manually filing away. So I'll get back to you later. Well, that seems to have turned out reasonably well. Okay, so the first thing I'm going to do is clean up the faces on this brass bearing. Okay, so just prior to cleaning up the faces, I also used the bench grinder just to clean up other areas, and I did a bit of hand filing as well. So having cleaned up the face, I marked out the centre in terms of where the bearing needs to be drilled. Now, I'm not very good at using a centre punch, and to be honest, that's a bit of a mess. So what I've decided to do is to put this back on the mini mill, and I'll use a little centre drill to get a more accurate sort of point. Having done that, then we can go back to the lathe and look to start drilling and reaming. Okay, so what I've just done is I used a centre drill and just lowered the head slightly so the centre drill was just touching the piece, and that enabled me to line up the x-axis. So I just touched the piece and then just turned the chuck, and as you can see, that little dot there is spot on the centre line. So I've locked the x-axis down, and now I'm just going to use this edge finder to find the edge, and I know that the y-axis needs to be moved 1/4 of an inch from that edge. So it's just found the edge there. So I'll zero the dial on the y-axis, put a centre drill in and move the y-axis that way a quarter of an inch. So I've moved the y-axis in a quarter of an inch, plus of course 3mm as well extra, which is half the diameter of the edge finder, and that's brought it spot on. So I'll just do a quick drill there. So that looks pretty perfect, so I'm really pleased I took that approach. So to get this centred in the 3-jaw chuck, apparently one of the methods is to use some packing like that. Push it right up so it's touching the base of the chuck. Tighten up. Just check. Symmetrical. Okay, so what I've got here is just a piece of rod that's got some pointed ends. Put one in there. On this side here, it's wood turning life centre, an Axminster one, which takes all different types of bits on the end, and this is concave in the middle, so I can push that up there, lock it down and give it a turn. Oops, that's not right, is it? Now, as you can see there's still a wobble on it, so I need to do some more adjustment. Well, after a lot of experimentation and changing the thicknesses of the packing, I'm sort of nearly there. I'm within 4 thou, which I think will be okay. And one of the key points I think you've got to make sure is that the actual end of the brass butts up against the bottom, or rather the top of the 3-jaw chuck. So let's crack on and start drilling. So I'm going to start off with a 3.5mm drill bit. I don't want to go too small in diameter, otherwise it might wander off. So I've just drilled with a 5mm and then a 6mm. This is a 6.8mm. I think ideally for a 9/32 reamer, that should be 6.9mm, but I've not got a 6.9, so 6.8 will have to do. I think that leaves about 15 thou for the reamer, which is probably, I guess, on the large side, but we'll see how we get on. Well, drilling with the 6.8mm drill bit seemed to be a bit of a challenge there, because it got sort of stuck in the brass and it started spinning the chuck. But anyway, I think I recovered the situation off camera, and Now I'm going to ream to 9/30 seconds, and I've decided to put some a little bit of tapping fluid on it to see if that helps improve things. So I'll run round about, I guess, 600 RPM. Withdraw it and move the tailstock up a bit. Well, this is the piece of bar that's going to be used for the crankshaft, and I've not done any work on this, but I just made sure there's no burrs on the end. And that does feel like a pretty good fit. I'm sure it'll run in a little bit. And if we switch the lathe on, feels pretty good. Well, it looks like a nice clean hole, and it's come out the other side okay, so I'm very happy with that. So now I've got to the point where I need to cut this in half to create the two bearings, so I'm just going to use a hacksaw to do that. Now I've also marked on here the correct dimensions to mill it down to, so that's 19/32 of an inch from this side, and that is 19/32 of an inch from that side. So I'll do that milling in the same way that I mill these sides and holding it in the vise, but I'll do all that off camera. Now, just as a precaution, I've labelled them up as left and right, and also put some die cam on this side. That's just in case I need to match these bearings up in the future, because obviously the hole was drilled as a complete piece, so it might be important later on to realign them in that way, if you get my drift. Well, they seem to have turned out okay, so my plan now is to make a mandrel to enable me to make the bosses on these bearings. Now, the mandrel will be made out of a piece of mild steel bar, and this obviously isn't to scale, but this section will be 1/2 inch long, which is slightly shorter than each of the bearings, and it'll be 9/32 in diameter, which is the diameter of the bearing, so effectively the bearings will just slot on there. And this section here will be about 1/2 inch long, turned down to about 1/4 inch diameter and threaded on the end. Now on this bit here, I'm going to make a bush. So this bush will have an inside diameter of 1/4 inch to enable it to slide on here, and an outside diameter of 27/64, which is the diameter of the boss that I need to make. So having put that on there and put the bush on there and tightened it up, I should be able to turn the boss quite easily, in theory. Well, I think this is my lucky day. I've just been rummaging around various boxes of things, and I came across a box that contained quite a few bits and bobs that I used when I maintained my MG Midget many years ago. And this is an accessory I found, and as I recall, I mean I could be wrong, but I think I used that to align the clutch when I replaced the clutch on the car. So this is extremely close to what I'm looking to make, to be honest. I can cut this end off. I can dispose of that. Now this section here is very close, if not identical to that section there. This piece of mild steel here, I think it is, I can use to turn down to make that little component that will slide on there. And all I need to do then is to turn this bit down to 9/32 in diameter for 1/2 inch in length. Perfect. So the width of the bearing is just over 1/2 inch. So I've set the tool there to be 1/2 inch in from the face, and I've set my carriage stop down here accordingly. So now it's just a matter of turning this down to 9/32 of an inch. That's looking good so far. So for the bush I've just decided to use this 3-jaw chuck, and there's a couple of millimetres to come off. Well, I've got a little bit of a dilemma here. I've turned this down to 27/64, and it only leaves about a thou to take off. So I think I'm going to take a little bit more off this bush. I'll probably reduce it to about 10mm. I don't think it's overly important. But anyway, that's what I'm going to do. Reduce it to 10mm, and then I can turn these bosses. Okay, so I've got another dilemma now, because the actual bosses, the width on each side is different. So one is 1/8 of an inch and the other's 5/32 of an inch. So assuming that the sort of crankshaft's going to be in there, I need to work out whether or not these inside ones should be 1/8 of an inch or 5/32 of an inch, because it's unclear from the drawings which way round it should be. Now, I've measured the inside of the sole plate where these bearings will fit, and that measures to be 0.910 of an inch. Now the crankshaft width is 5/8, which is 0.625 of an inch. So if I assume that the inside boss here is going to be 1/8 of an inch, that's going to be multiplied by 2, which comes to 0.025. Add these two together and I get 0.875 of an inch, which is less than 0.910. So what is it, about 35 thou difference, which is probably okay for a little bit of play. However, if I was to go with the larger boss on the inside, this 5/32, if I multiply that by 2, I get 0.3125. Add 0.3125 to 0.625, I get 0.937, which is bigger than the inside width of the sole plate. So that to me proves that the inside boss must be 1/8 of an inch. Okay, so I've set the carriage stop to be 1/8 of an inch, and I'll machine this boss down so it's level with this bush here. Once I've done that, I'll switch it round and do the other side of the boss, which needs to be 5/32. go about 400 RPM initially. Looking good. Well, that was an interesting little exercise, and I think the scariest moment was when I loosened the tailstock with the machine under power. It's something I've done quite often when I've been wood turning in the past, but I think with cutting brass, the brass just dug into the bit and just pulled the whole thing forward. So I'm not really too sure what the solution is there, but if anybody's got any advice on that, I'd really appreciate it. But anyway, the mandrel turned out really well, so I'm really happy with the way that worked. And all in all, I think the bearings have turned out really well, so I'm really happy with the result. And I hope you like the result so far.